The Fell was the strangest locomotive Britain ever built, and if you've ever taken the train north out of Manchester and felt it climb into the Pennine Hills, you followed the road it once worked. 6 diesel engines, one of a kind, 2,000 horsepower, hauling 12-coach expresses over the peak, outpulling the finest steam engines on the line. It survived the doubt of an entire industry that called it a folly. It survived the trials that would have found out any weakness. It kept its trains on time, over the hardest railway in England, for years. And then, after barely 6 years of service, the most complicated machine ever to run on British rails was quietly cut up in a siding, until nothing of it survived but a model small enough to sit on a table. How does a locomotive that beats steam over the Pennines simply vanish, so completely that almost nobody alive has heard its name? Chapter 1. The Colonel. The story begins in a bedroom, not a drawing office, not a boardroom in the city, a bedroom in the grey years after the war, where a man in late middle age sat hunched over a drawing board he'd wedged in beside the bed, working by lamplight long after his proper day's work was done. He was designing a locomotive. He believed it would save an industry. And by the reckoning of the men who eventually built the thing, he was very nearly right. His name was Louis Frederick Rudston Fell. To the railway world, he was Colonel Fell, or simply the Colonel. Lieutenant Colonel, to be precise, a rank earned in the mud and oil of the First World War and carried with him ever after, into every committee room and every argument about the future of British traction. He was born on the 13th of January, 1892, at East Ayton, a village near Scarborough on the North Yorkshire coast. His people were comfortable, county sort. His father a justice of the peace, the family the kind that educated its sons properly and expected them to make something of it. Rudston, as the family called him, went to school at Windsor. He might have drifted into a soft profession. Instead, at 15, he went to learn engines. That's the first thing to understand about the Colonel. He wasn't a gentleman who dabbled in machinery. He was a craftsman who happened to have been born a gentleman, and the two things sat awkwardly together for the whole of his life. The apprenticeship is where the record gets tangled, and it's worth being honest about it. The family's own account puts him at Clayton and Shuttleworth, the great agricultural engineering firm in Lincoln, from 1907, learning about internal combustion engines and, crucially, about gearboxes, knowledge that would matter enormously only a few years later. Another account has him at the Great Northern Railway's works at Doncaster, learning locomotives from the footplate up. In all likelihood, it was both, one after the other, because that was the shape of a thorough engineering education in Edwardian England. What isn't in doubt is that the young Fell learned to drive a steam locomotive, and that he was, from the beginning, the sort of man who wanted to know exactly how a thing worked before he'd trust it. There's a story from those Doncaster days that the family loved to tell. Fell, firing on a footplate, decided to have a bit of fun and turned on the blower, the steam blast that draws air through the fire. The draft was so fierce it lifted the fireman's meat pie clean off the shovel and sucked it away up through the boiler tubes. It's a small thing, but it tells you the young man already understood, in his bones, what a column of forced air could do inside a machine. He would spend the best part of his life on exactly that idea. Then came the war, and it made him. He enlisted in the Royal Navy in September 1914, transferred to the Royal Flying Corps, and rose fast, second lieutenant, captain, and finally, lieutenant colonel, running the Royal Air Force's engine repair station at Pont de l'Arche in France. This was not glamorous work. It was the unglamorous, essential business of keeping aero engines alive, stripping them, diagnosing them, rebuilding them by the hundred while the war ground on overhead. He was mentioned in dispatches 4 times. He came home with the Distinguished Service Order, and later, the Order of the British Empire. He came home, above all, as a man who understood the internal combustion engine more intimately than almost anyone alive. And he was, by every account, a genuine force of nature. His son John, who would grow up to become his father's apprentice, and later the keeper of his story, remembered him as almost frighteningly strong. Once, at the trackside, a steel shaft weighing 400 weight, the better part of 1/4 of a ton, needed shifting off the rails. Fell picked it up, one-handed, casually, the way another man might move a length of timber. He detested snobbery with a peculiar intensity, all the more striking in a man of his background. When his Rolls-Royce colleague Robotham rubbed him the wrong way, Fell took to pronouncing the name Rowbottom and went on doing it. He kept every tool he owned in what the family called apple pie order. He had built, in his time, a compound steam engine and a motor car, both largely with his own hands, some of it alongside his mother. He had a public school voice that the rough men at Doncaster mocked mercilessly, and he didn't care in the slightest, because he could outwork and outthink most of them, and they knew it. His sister, as it happens, was Dame Honor Fell, one of the most distinguished cell biologists of the century. It was that kind of family. They believed in doing difficult things properly, and in sharing what they learned. After the war, the colonel went where the engines were, the Air Ministry's Research Directorate, then Rolls-Royce, where he worked on the power installation of the Merlin, the engine that would one day carry Spitfires and Hurricanes and Lancasters. A spell at Armstrong Siddeley in Coventry, back to Rolls-Royce again by 1939, chief power plant design engineer, running offices at Belper and Hucknall. By the middle of the war, he was a technical sales manager. He had spent 30 years at the absolute centre of British engine design. And somewhere in all that, he arrived at a conviction that would consume the rest of his life. The conviction was this: everybody trying to replace the steam locomotive was doing it wrong. The obvious answer, the one the industry was reaching for, was the diesel-electric, a big diesel engine driving an electrical generator, the generator feeding electric motors on the axles. Fell thought it a nonsense. A diesel-electric, he said, was a power station on wheels, heavy, expensive, and wasteful, because it burned fuel to make electricity less efficiently than a proper power station on the ground ever could, and then it had to haul all that dead electrical weight around behind it. His answer was different, and it was radical. Don't build one enormous engine. Build several small, fast, mass-produced diesels, the kind of engine already being turned out by the thousand, and combine their power mechanically. Several small engines would be cheaper, even taken together, easier to service. You could spread them through the frame for even weight on the rails and better grip, and because they were ordinary production engines, spare parts would be everywhere, and reliability would look after itself. But there was a second argument underneath the engineering one, and it mattered even more to him. His locomotive, he said, would be so simple that railwaymen could build it themselves. At Derby, in the workshops that had built steam engines for generations, the diesel-electric would have to be bought in from the great electrical firms. The work would leave, the skills would leave, the jobs would leave. Fell's machine would keep all of it at home. He was not, in the end, only designing a locomotive. He was trying to save a way of life. He simply didn't know yet how completely the odds were stacked against him. Chapter 2. A Marriage at Derby. On the 1st of January 1948, the railways of Britain were nationalised. The old Big Four, the Great Western, the Southern, the two great rivals of the North, vanished into a single organisation, British Railways. And what British Railways inherited was, to be blunt, exhausted. The steam fleet was worn thin by 6 years of war and no maintenance. The country was broke, repaying an enormous debt to the Americans, rationing still biting. Coal was cheap and British. Diesel oil was expensive and imported. Everyone agreed the future was coming. Almost nobody agreed on what it looked like. Into this uncertainty walked Colonel Fell, with his drawings and his conviction, and he took them to the one man in the country who could say yes. Henry George Ivat was the last chief mechanical engineer of the old London Midland and Scottish Railway, and now the chief engineer of British Railways' London Midland region. He was Derby's man, and when Ivat heard what Fell was proposing, a mainline locomotive that Derby could build with its own hands, using ordinary engines and mechanical gears, cutting the great electrical firms out entirely, he was, by the family's account, overcome. He fell on Rudston's neck. Because Fell's scheme wasn't just an interesting bit of engineering, it was a lifeline for the works Ivat loved. The two men became close friends, as it turned out. They shared a weakness for antiques. Ivat collected old clocks, Fell restored an organ. But the friendship began in a shared belief that Derby had a future worth fighting for. Fell didn't come empty-handed. Around him he'd assembled a consortium, and the names in it were among the best in British engineering. He formed a company, Fell Developments Limited, registered at an address in Bishopsgate in the City of London, to own and develop his ideas. Its shareholders were Fell himself, the great oil firm Shell, which had an obvious interest in a locomotive that burned oil, and the engineering consultancy of a man whose name meant more in the world of the diesel engine than almost any other. Sir Harry Ricardo was the closest thing British engineering had to a wizard of combustion. It was Ricardo who had cracked the problem of how to burn diesel fuel cleanly and efficiently in a high-speed engine. His combustion chamber design, the Comet, was licensed the world over and sat inside diesels on every continent. He'd been knighted for it. He was also Fell's personal friend, and his firm held the rights that would make the whole scheme possible. Every single combustion chamber in Fell's locomotive would carry a Ricardo Comet head, all 60 of them. For the main engines themselves, the consortium went to Colchester, to V12 Paxman and Company, an old and respected maker of diesel engines. Paxman would supply the power, and Paxman brought its own people into the story, men who would watch this locomotive from cradle to grave and leave us the most honest testimony we have about it. There was John Cove, who joined the firm in 1948 and would later sit on the design committees, our best first-hand witness to what really happened. There was Jeff Bone, who would run Paxman through the crucial years. There was Dick Stockings, who led the firm's rail traction engineering. These were not dreamers. They were hard-headed engine men, and they were about to build something none of them had ever seen the like of. In 1948, the railway executive concluded a contract with Fell Developments to build a single prototype, one locomotive. The consortium would fund it, and at first, own it. British Railways would provide the works, the labour, and the running. And here is the detail that history tends to forget. The railway unions loved it. They loved it because Fell's argument had landed exactly where he'd aimed it. A diesel mechanical locomotive built at Derby by railwaymen using British engines threatened nobody's job. The diesel-electric, bought in from the electrical giants, threatened a great many. For a brief moment, the Colonel's strange machine was the one everybody could get behind. Management, unions, the men on the shop floor. It felt less like a gamble and more like a homecoming. But even as the contract was signed, the ground was shifting. Because the electrical firms had not been idle, English Electric had already built 2 diesel-electric locomotives for the London Midland, numbered 10,000 and 10,001, the first outshopped in December 1947, presented to the press with real fanfare. They were proven technology, backed by an industry with enormous momentum and enormous influence. The Colonel's locomotive would be the outsider from the first day, the only mainline diesel mechanical contender in a field already tilting the other way. None of that was visible yet in the paint shop at Derby, where the strangest locomotive Britain would ever build was about to take shape. First, though, the men had to build the thing at the heart of it, the one component on which everything else depended: the gearbox. Chapter 3. The gearbox that ran backwards. To understand what made Fell's locomotive extraordinary, and to understand in the end exactly how it would die, you have to understand the gearbox. Everything came down to the gearbox. The problem the Colonel had set himself was this: he wanted 4 separate engines to drive one set of wheels, all together, their power combined into a single output. Nothing on the railway did that. So he reached back to the thing he'd learned as a boy at Lincoln, and he did something beautifully simple and slightly mad. He took the differential, the ordinary gear at the heart of every motor car, the one that lets the driven wheels turn at different speeds around a corner, and he turned it back to front. In a car, one engine feeds power in, and the differential splits it out to 2 wheels. Fell reversed the flow. He put an engine on each of the 2 outputs, fed their power in from both sides, and took the combined power out through what would normally be the input. 2 engines, 1 shaft. Then he did it again with a second pair, and then he fed the outputs of both those units into one final differential, which delivered the whole lot, 4 engines worth of power, down to the driving wheels through a final reduction gear. Each engine connected to the gears not by a solid coupling but by a fluid one, a Vulcan-Sinclair hydraulic coupling, essentially 2 fans facing each other in a bath of oil. Fill it with oil and the engine drives. Drain it and the engine spins free, disconnected. The driver could bring engines in and out simply by filling and emptying these couplings with a flick of a scoop. It was elegant. It gave him a way to add engines one at a time as the train gathered speed. Now here is the part that almost everyone gets wrong, and it's the key to the whole machine. A car gearbox multiplies torque. You change down, and the engine's turning force is magnified to get you up the hill. Fell's gearbox did no such thing. It couldn't. All it did was change the speed. With 1 engine engaged, the ratio to the wheels was 4 to 1. With 2 engines, 2 to 1. With 3, 1 1/3 to 1, with all four 1 to 1. Adding engines didn't add pulling power, it added speed. The full pulling force of the locomotive, the maximum turning effort at the wheels, was available on a single engine. The other three were there to let it go faster, not to let it pull harder, which leaves a very obvious question hanging in the air. If the gearbox couldn't multiply the pulling force, if it gave you speed and nothing else, then where on earth did the locomotive get the enormous grunt it needed to drag a 12-coach express away from a dead stand on a Pennine gradient? Hold that question, because the answer is where this locomotive stops being merely clever and becomes genuinely unlike anything else that ever ran on rails. The gearbox itself was a monster of a thing, built, according to John Fell, by the Huddersfield gearmakers David Brown, though the mainstream technical accounts never name the maker, so we pass it on as the family remembered it. His father's son thought it looked sitting there in the frame, rather like an elephant with a throne on its back. It was the single most complex mechanical assembly in any British locomotive, before or since. 4 engines poured their power into it. 1 set of wheels took the power out, 1 gearbox. 4 engines, depending on it utterly. If it ever failed, every last one of them would be driving nothing at all. Nobody was thinking about that in 1949. They were thinking about the engines, and there were rather a lot of them. Chapter 4. 6 engines and a scream of air. 4 main engines. That was the plan, and 4 is where a sane design would have stopped. They were Paxman engines from Colchester. 12-cylinder diesels, arranged in 2 banks of 6 in a broad V, each one giving 500 brake horsepower at 1,500 revolutions a minute. 4 of them. 2,000 horsepower of traction, more than any non-steam locomotive then running on British metals. They sat in pairs under bonnets at each end of the machine, with a full driving cab at either end. Every cylinder carried one of Ricardo's Comet combustion chambers, 60 combustion chambers in all, firing away inside a single locomotive, and the men who ran them could hardly fault them. John Fell said the Paxman mains, to the best of his knowledge, never gave a minute's trouble the whole time she was in service. It was everything wrapped around them that caused the grief. But the engines themselves, the beating hearts of the thing, those were sound. Except 4 engines alone couldn't answer the question we left hanging in the gearbox. The transmission gave speed, not pulling force, so the pulling force had to come from somewhere else. It had to come from the engines making their maximum effort not at high speed, where engines like to work, but right down at the bottom, at a crawl, dragging the train off the mark. Getting a diesel to make its hardest effort at low speed means one thing. It means forcing air into it, supercharging it hard when the train is barely moving, and easing off as it speeds up, and forcing that much air needed power of its own, a great deal of power. So Fell added 2 more engines. This is the detail that makes people stop and stare, and rightly so. The Fell locomotive carried 2 additional diesel engines, 6-cylinder AEC units of the kind used in buses and marine work, 150 horsepower apiece, whose entire purpose in life was to drive the blowers that fed air to the other 4. They didn't turn the wheels. They didn't touch the gearbox. They existed solely to breathe for the main engines, to run the great Roots-type blowers that rammed air into all 60 cylinders. They also drove the radiator fans, the oil pumps, the vacuum gear, the generators. But their headline job, the reason they were there at all, was to feed the beasts. 6 engines, 4 to drive the wheels, 2 just to make the wind. And when those 2 auxiliary engines were working flat out, in a station, at full boost, ready to heave the train away, the noise was something the men never forgot. John Cove described it plainly. The noise from those blower engines was hideous. So hideous that when the Fell passed by, the service engineers from the rival firms would make a great show of it, stopping, turning, and ostentatiously blocking their ears. It became a little ritual of mockery. It also, though nobody was laughing about it yet, told you something true. This was a machine that had to scream for its air. They built her at Derby Locomotive Works through 1949 and into 1950, assembled, of all places, in the paint shop, because it was the cleanest large building they had. And young John Fell was there for the whole of it, spending every Saturday at the works, watching his father's drawings turn slowly into iron and steel and that impossible gearbox. The colonel himself was so completely absorbed that by the family's telling, he once pinched a handmade screwjack that John had built during his own apprenticeship, quietly appropriated it to prop up the locomotive's frame, because it was exactly the right tool, and he wasn't going to let sentiment stand between him and the job. She emerged in plain black. Nationalisation had happened while she was being built, so there was no grand livery. Just British Railways black over that vast, strange body. A locomotive, 50 feet long on 8 coupled wheels. 2 cabs, 6 engines, and a number. 10,100. It slotted her into the little family of experimental mainline prototypes that British Railways was trying out. The others were all diesel electrics. She was the only diesel mechanical among them. The outlier. The odd one out from the very first day she carried a number. And then, one day in November 1950, in the yard at Derby, they tried to move her under her own power for the first time. She wouldn't go. 6 engines ready, 60 cylinders warm, and the most complicated locomotive in Britain sat exactly where it was and refused to budge. The men checked and checked again, and eventually gave it up for the day, baffled. It was only the following morning that somebody found the cause. A pipe had been left disconnected during the build. The brakes had never come off. All that power, all that ingenuity, held fast by an unconnected airline and nobody the wiser until morning. You could take it as a comedy. The Colonel, one imagines, took it as a lesson, because it was a small, almost funny illustration of the exact thing that would one day destroy her. That in a machine, this complex, this dependent on every single part playing its role, the smallest overlooked component could bring the whole magnificent edifice to a dead and total stop. They found the pipe, they connected it, and this time, when they opened her up, 10,100 moved. The strangest locomotive Britain ever built was finally alive. Now it had to prove it could run. Chapter 5. She moves. There is a particular quiet that settles over engineers when a machine they've argued about for years finally does the thing it was built to do. In the early weeks of 1951, out on the metals at Derby, the men who'd built 10,100 got to feel it. She ran. Not the stammering, brake-locked embarrassment of that first November afternoon, but properly, out onto the main line under her own power, a load behind her, doing the work she'd been dreamed up for. And the very first thing everyone noticed was how she left a platform. A steam locomotive starts with a lurch and a slip. A great heave of driving wheels biting and losing their grip and biting again, the couplings snatching taut one after another down the length of the train, so that a passenger halfway back feels the whole thing come to life in a series of jerks. The Fell did none of that. The driver eased his levers, the fluid couplings filled with oil, the power came on smooth and unbroken, and the train simply gathered itself and went. No lurch, no slip, no drama at all. John Fell, riding in one of the coaches on an early run, remembered the strange disbelief of the moment he realised the platform was already sliding past the window, that they were moving, had been moving for some seconds, and he had felt nothing, no sensation of starting, just the world beginning, gently, to travel. At rest she was stranger still. A diesel of that era announced itself for what it was, the hard, knocking clatter of compression ignition, the sound of lorries and buses, the sound a lot of steam men frankly despised. The Fell hardly made it, because her cylinders were so heavily supercharged, the air was already crammed in tight, even at idle, and the diesel knock that plagued lesser engines all but disappeared. She ticked over, one man said, admiringly, as quietly as a luxury motor car. 6 diesel engines aboard, 60 cylinders, and standing at a platform she did little more than murmur. She even had a voice of her own, and it came about by accident. When they wired up her air horns, somebody got the connections crossed, so that instead of a single note, she sounded a chord, a soft minor third, oddly musical, more the sort of thing you'd expect from an organ than a locomotive. Fell, who kept an organ at home and loved the thing, can hardly have minded. His machine announced itself down the Midland line with a wrong-wired harmony, and nobody troubled to correct it. Then they tested her in earnest, and testing was not a gentle business. They coupled a dynamometer car behind her, a special coach packed with instruments and men, its recording gear drawing out on long rolls of paper exactly what she pulled, how hard, at what speed, against what resistance. A dynamometer car is a machine for finding out the truth, and it does not flatter. Some of that testing took her over the Settle and Carlisle, the great switchback line flung across the high backbone of northern England, where the gradients run for mile after mile, and there is nowhere for a struggling engine to hide. This was the trial that mattered. On the long climbs, a locomotive either has the power in hand or it doesn't, and every man aboard would know which within the hour. She had it in hand. The inclines held steady where a weaker machine would have faltered. She was measured and weighed and understood, and what the figures showed, set down in black and white by instruments that had no stake in the argument, was that the Colonel's impossible idea worked. 4 small engines and a mechanical gearbox could haul a real train over real mountains. It was no longer a theory drawn on a board in a bedroom. It was a fact, printed on a roll of paper in a swaying coach somewhere on the roof of the Pennines. The men who doubted her began cautiously to stop doubting. Chapter 6. Supercharged Sports Model. For a few brief months in 1951, before the hard daily grind of service swallowed her up, they showed her off. It is worth being clear-eyed about what that amounted to because it is the nearest this locomotive ever came to fame, and it wasn't very near at all. She went first to an exhibition at Eastbourne, laid on chiefly for railwaymen, the drivers and fitters and engineers who might one day have to run and mend machines like her. And to Eastbourne, Fell brought his mother. Alice Fell was by then an old woman, but she was not an ordinary one. Decades before, she had built a motor car with her son. Actually built it, with her hands, the two of them working through the problem together. She came from a family that did difficult things and expected to understand them from the inside. And so, at Eastbourne, Alice Fell was helped up the steps and into the cab of the strangest locomotive in Britain. Her son's life's work in iron and steel all around her, the 4 little engine levers under her hand, the impossible gearbox somewhere beneath her feet. Picture it, an elderly woman sitting in the driving seat of a 6-engined machine that half the industry thought a folly, because her boy had built it and she wanted to see. It is a small and tender scene. It deserves to be remembered, because there were not going to be many more days as bright as that one. From Eastbourne, she travelled to Marylebone to be shown to the general public. And here she was, a curiosity and little else. An oddity wheeled out for the enthusiast and the idle passer-by to gawp at. A locomotive with a number and no name and far too many engines. The humour magazine Punch marked the occasion with a cartoon by Brockbank, which captioned her, with gentle mockery, "Supercharged Sports Model." A little joke about this overpowered, over-engined beast. And that, in all honesty, is the summit of the Fells' public life. Not a nation holding its breath. Not headlines. A cartoon in a humour magazine and a few hundred railwaymen filing past her in an exhibition hall on the south coast. She was never going to be a household name, never going to be a Flying Scotsman or a Mallard, never going to lodge in the national memory. She had no speed record, no royal occasion, no famous run. She was one strange black machine, admired by the few people equipped to understand what she was, and unknown to almost everyone else. But those few people understood something the crowds at Marylebone could not. They understood that the joke in Punch was, in its way, precisely right. She was a supercharged sports model, a machine that took the ordinary idea of a diesel locomotive and pushed it to an extreme nobody else had dared. And they knew that the real test of her wasn't an exhibition hall. It was the fast line to Manchester, 12 coaches on the drawbar, the peak to climb, and a schedule to keep. That was where she would either prove the Colonel right or prove him a dreamer. In 1952, they found out. 10,100 entered scheduled passenger service, and the exhibitions were over. Now she had to work for her living. Chapter 7. The Fast Line to Manchester. They put her on the expresses to Manchester, and there was no harder proving ground on which to put her. Her home became the Midland Main Line, the fast trains out of St Pancras, up through Derby and Belper, over the high peak country and down at last into Manchester Central. It is unforgiving railway. Long, grinding gradients climb through the Pennine Hills. Tunnels run dead straight through the living rock, and the whole route had always demanded the biggest and best express engines the Midland could find for it. Now it demanded them of the Fell. She took 12 coach trains over it, full-length expresses, the genuine work of a mainline railway, with paying passengers behind her and a timetable that did not care in the slightest how many engines she carried. She was expected to keep time. And to keep time over the peak, a man first had to learn to drive her, and driving her was like nothing else on the network. Picture the cab. Alongside the regulator and the reversing lever sat a row of 4 small levers, one for each of the main engines. And here was the thing no other locomotive in Britain asked of its driver. You did not simply open the regulator and go. You started your engines one at a time, on the move, as the train gathered speed. You began on a single engine. On that one engine, she would pull her train away from a stand and take you up to something around 6 miles an hour. Then you brought in the second, a flick of the scoop, the coupling filling, the note deepening, and the pair of them carried you on to about 17. The third came in next, good for perhaps 24. And only then, with the train properly rolling and the road opening out ahead, did you engage the fourth and last engine, which would run her all the way up to her authorized limit of 78 miles an hour. Some later accounts credit her with a little more. She was certainly clocked at 78 on a trial run near Luton, flying. It was, in the plainest sense, changing gear. But changing gear by summoning whole engines to life, one after another, feeling her note climb each time another 500 horsepower took up its share of the load. A driver couldn't do it by numbers off a card. He had to feel it. He had to know the road intimately, know the weight behind him, know the exact instant to bring the next engine in so that the train never checked, never faltered, on the long pull up the bank. Get it right, and she flowed up the peak like water, finding its level. Get it wrong, bring an engine in too early, too late, and you'd have her labouring or racing uselessly, the whole delicate balance thrown out. She was, in the deepest sense of an old railway phrase, a driver's engine, and she found the driver she deserved. His name was Jim Lowe. By every account that survives, Jim Lowe was a gifted man, sensitive and capable, the two words that come up again and again. Sensitive in the particular way the very best drivers are, able to read a machine through the soles of his boots and the palms of his hands, to feel a slip or a strain half a second before it showed. He learned her, not the way you learn a set of instructions, but the way a musician learns an instrument, until the four levers, and the road and the load and the note of the engines all fused into a single thing in his head, and he simply played her. It was said he could very nearly make her sit up and beg, and he gave this one-off, experimental, supposedly troublesome machine something such a locomotive almost never earns, a genuinely enviable record for keeping time. Trains ran, and ran to schedule, behind an engine that a good part of the industry regarded as a curiosity that would never come to anything. He was not alone in loving her. There was a second driver, an old steam man, whose name has not come down to us, who took to the fell and preferred her to anything else he drove. That is worth pausing on, because it is not a small thing. Steam drivers were not, as a breed, quick to warm to diesels. These were men who'd given their whole working lives to the footplate of proper engines, who felt the coming of oil as a kind of bereavement, a diminishment of the craft they'd mastered. For one of them to actively love the fell, to climb down off a Jubilee and be glad he was taking the strange 6-engined machine out instead, told you she had something real in her. She wasn't merely clever on paper. On the road, in the right hands, she was a pleasure to drive. And down there in the cab, out over the peak, with 12 coaches behind and the engines coming in one by one and the wrong-wired horns sounding their soft minor third at the tunnel mouths, 10,100 was doing precisely what the Colonel had promised in that bedroom, night after night, against the whole weight of expert opinion. She was doing the work of the biggest steam express engine on the line, and doing it more smoothly, more quietly, and, as it turned out, more cleanly than steam had ever managed. Cleaner, in fact, than anyone had thought to expect. Chapter 8. The Measure of Her. Here is the odd-telling detail that shows you, better than any dynamometer roll, what the fell was actually doing out on the Midland line. She cleaned the tunnels, her exhaust blasted out sideways, hard and hot, and as she drove through the long Pennine tunnels that side blasts scoured the walls. For the best part of a century those tunnels had worn a thick, greasy coat of steam soot, black, clinging, ancient. The fell began stripping it off, and there was a consequence nobody had foreseen. For a while, the trains that came through behind her arrived at the far portal absolutely filthy, showered with the loosened muck of decades, until at last the tunnels had been scrubbed clean by her repeated passing. A locomotive that cleaned the very tunnels she ran through. It is a small thing, but it tells you she was a genuinely different kind of machine, doing genuinely different things to the railway around her, reaching into places a century of steam had blackened, and without meaning to, wiping them clean. Now for the number, because there is one, and it is the true measure of her, and it should be allowed to land on its own. Out on those Manchester expresses, hauling the same loads over the same hard road, 10,100 was reckoned to be around 25% more powerful than the Jubilees, the handsome three-cylinder engines that were the pride of the Midlands express fleet. A quarter more power than the best steam locomotives she ran beside. Not in a laboratory, not on a favourable trial. In ordinary daily service, on real trains, in the hands of Jim Lowe. She could exert £25,000 of tractive effort at 12 miles an hour. Real pulling power, low down, exactly where an express needs it to heave its train away and up the first bank out of the station. And Jim Lowe, who understood her better than any man alive, had found a way to wring even more out of her. On a difficult start, one of those cruel Pennine grades where you needed everything at once and the book said you couldn't have it, he'd play the oil scoops of the second, third and fourth engines in a particular practiced way, so that for one crucial moment the spinning inertia of their fluid couplings added itself to the pull of the first engine. It gave her a sharper, harder getaway than her own design was supposed to allow. It was virtuosity, pure and simple. A man and a machine working right at the outermost edge of what was possible and getting away with it. It kept his trains on time. It also, though not a soul suspected it yet, was quietly storing up a debt that would one day come due with terrible interest. But that is a later chapter. For now, it was simply beautiful driving. And it all pointed to one conclusion, the conclusion that mattered more than any exhibition or cartoon or clocked top speed. The verdict came, fittingly, not from the Colonel, who believed in her as a father believes in a child and could hardly be called impartial, but from John Cove, the Paxman man, one of the coolest and least sentimental witnesses in the whole story. The locomotive, Cove said, was extensively tested and did prove the viability of an entirely mechanical drive for a locomotive of that power. That is the sentence to hold on to, from Paxman. From the hard-headed engine men who had built her mains and had every reason to be sceptical of the impossible gearbox they were bolted to. She worked. The idea worked. A purely mechanical mainline locomotive of 2,000 horsepower was not a fantasy. It was running expresses to Manchester and beating steam over the peak. This was the summit. It has to be named plainly because it looks like no other summit in these stories and the eye slides straight past it. There was no fleet of fells, no headlines, no cheering. The peak of this whole saga is one black locomotive running well, keeping time, quietly proving a thing the entire industry had assumed could not be proved. That is the entirety of her golden age. Brief, modest, and completely real. And somewhere around then, Lewis Fell must have let himself believe, for a while, that he had won. He had not, and the reason he had not was already in place, arranged against him while his back was turned, in the years he'd spent bent over that drawing board. The tide had gone out from under her even as she was being built. English Electric's diesel electrics were already running, backed by an electrical industry with deep pockets, huge momentum, and the ear of the men who would decide the shape of the future. A great modernization of the railways was coming, and when it came, it would ask one blunt question, mechanical transmission or electrical, for the whole of British railways at a stroke, and it would not answer that question in the Colonel's favour. Everything that made the Fell magnificent also made her utterly alone. One locomotive, one gearbox, one idea, with no class behind her and no place reserved in the plan. She had proved she could work. She had never been given the one thing that might have saved her, which was numbers. At the very moment of her triumph, she was already an orphan. She simply didn't know it. Neither did the men in the cab, bringing the engines in one by one over the summit of the peak, keeping their trains to time behind a machine they had come to love. The first blow was already on its way, and when it came, it would strike at exactly the point where the whole daring design was weakest, through that single, magnificent, irreplaceable gearbox, and it would be delivered, of all things, by one loose bolt. Chapter 9. The Trouble with Cleverness. Cleverness has a cost. The Fell was the cleverest locomotive Britain ever built, and she began, almost from the first, to pay for it. The trouble was written into her from the day she was drawn. Everything about her was more complex than it needed to be, not out of carelessness, but out of conviction. The colonel had decided, on principle, that everything aboard should be driven mechanically, no electrical shortcuts, no easy compromises. And so, where another designer might have run a small electric motor to turn a radiator fan, the Fell turned hers with shafts, long shafts, running the length of the machine, driving the fans and the pumps and the exhausters through gears and couplings and yet more moving parts. John Cove, looking back with an engineer's unsparing honesty, put his finger on exactly this. The decision that everything be mechanically driven, he admitted, led to a complex and troublesome arrangement of long shafts driving the auxiliaries. Every one of those shafts was a thing that could wear, misalign, fail. She was a machine that had multiplied her own opportunities for going wrong. The cooling was the worst of it. Her radiators sat at the extreme ends of the locomotive, and that was a mistake with teeth in it. When she ran, the trailing radiator, the one at the back, was blanked off by the train coupled behind her, starved of the very air it needed to do its job, and to feed cooling water to 4 main engines and 2 auxiliaries meant a maze of cross-connections, pipes running everywhere, a system so tangled that it fought against itself. It trapped air where it needed water. It ran hot where it needed to run cool. It gave, in Cove's flat phrase, a lot of problems with air venting and overheating. A locomotive that had to scream for its air also struggled, constantly, to keep its own temperature down. The 2 auxiliary engines had their own early agonies. Set to run flat out for hours on end, a duty no bus engine was ever designed for, they blew their head gaskets. And when they weren't failing, they were deafening. That hideous noise the rival firm's men made such a show of blocking their ears against. What had seemed, on the drawing board, an elegant solution to the problem of forcing air, turned out in service to be 2 more engines to nurse, 2 more things to break, 2 more sources of trouble in a machine already overflowing with them. Paxman's own verdict, when it came, was brief and final. The complexity of the Fell made maintenance time-consuming and expensive. That sentence is an epitaph in miniature. Every hour she ran, she demanded hours in the shed. She was a thoroughbred that needed a groom for every leg. And under all of it, beneath the shafts and the cooling and the screaming auxiliaries, sat the one flaw that mattered more than all the others put together. The flaw that had been there since Chapter 1, quiet and patient, waiting. 1 gearbox, 4 engines, but 1 gearbox. A diesel-electric locomotive that loses a generator or a traction motor limps on, wounded but moving, its faults contained within separate systems. The Fell had no such mercy in her. Everything she had, all 4 engines, all 60 cylinders, all 2,000 horsepower, poured into a single mechanical assembly, and out of that assembly came every last ounce of her ability to move. If the gearbox failed, she did not limp. She stopped, completely, and all at once. The most powerful non-steam locomotive on the network, reduced in an instant to 50 feet of dead weight on the rails. Everyone who understood her knew this. Nobody could do anything about it, because it wasn't a fault to be fixed. It was the design itself. It was the price of the whole idea. In July of 1952, the bill arrived. Chapter 10. 1 bolt. It was a bolt, that is the whole of it, and the enormity of it. Somewhere in the upper part of that great gearbox, the elephant with a throne on its back, a single bolt failed. Not a boiler explosion, not a catastrophic seizure, not some vast, dramatic rupture. A bolt let go, and in a machine of that precision, with gears meshing under the load of 4 engines, a loose piece of steel has nowhere to go but down. The broken bolt fell into the gear train, and it was carried down through the whole of it, from top to bottom, smashing between the turning wheels, and it rendered most of the gear wheels unfit for any further service. Consider what that meant. The single most complex mechanical assembly in any British locomotive, the irreplaceable heart of the entire design, wrecked from the inside by 1 failed fastener. There was no spare gearbox. There could not be. There was only 1 locomotive. To put her right meant stripping that monstrous thing down, machining or replacing rank after rank of ruined gears, and rebuilding it, gear, by hand. She was out of service for over a year. Over a year. A locomotive, built to prove a point, to run day in and day out and demonstrate that the mechanical idea could hold its own, sat crippled and silent in a shed, while the world she was meant to convince got on with deciding against her. Every month she stood idle was a month the argument was lost by default. John Cove, asked what had gone wrong, gave the honest answer, which was that he couldn't be sure. Whether it was the design of the bolt, or the material it was made from, or a flaw in the workmanship that fitted it, he could not say. The failure was real. The reason for it stayed maddeningly out of reach, and in a way that uncertainty was the cruelest part of all, because it meant nobody could stand up and say, confidently, that it had been put right and would never happen again. But here is the thing that the family, and the enthusiasts, and even Fell himself tended to look past in later years, fixing instead on the fire that came 6 years afterwards. Cove was clear about it. It was not the fire that killed the Fell. It was this. This bolt, this year out of service, this early and unanswerable failure of the one component that could not fail. In Cove's judgment, the 1952 gearbox failure probably influenced British Railways' decision not to proceed with the planned second, improved version, the Mark II that would have carried the idea forward and turned a one-off into a class. It was, he said, effectively the end of the project, in 1952. 6 years before she burned, and while she still had good running left in her, the future had already quietly closed. She was rebuilt, in the end, and she went back to work, and she ran her Manchester Expresses again, and Jim Lowe drove her, and for a while it must have felt as though the worst was behind her. It wasn't, because British Railways, having had one long, expensive, unanswerable fright, had begun to lose interest. Not dramatically, not with any single decision anyone bothered to minute. Just a cooling, a drift of attention towards the diesel electrics that didn't do this sort of thing. The Fell went back on the fast line, but she went back as a machine her owners had started, very quietly, to give up on. And the next blow, when it came not from the gearbox at all, but from something smaller and stranger, and rooted in an argument between two men over whose job it was to top up some oil. Chapter 11. The Hot Box at Luton. The Fell carried on her axles a piece of engineering that was genuinely ahead of its time, and it undid her. Her axle bearings were Timken taper roller bearings, an American design, and their fitting to a British mainline locomotive was a first for the country's railways. In principle, they were superb, stronger, smoother, better than the plain bearings of the old tradition. In principle. But taper roller bearings of that kind needed oil, kept topped up in their reservoirs, and keeping them topped up was somebody's job. And that, it turned out, was where the whole thing came apart. Not in the metal, but in the men. Timken had seconded one of their own fitters to look after the bearings, an expert sent to nurse this novel American technology on its unfamiliar British machine. And at some point, this Timken man and one of the railway men had a row. We don't know quite what was said. We know only what it led to, which was catastrophe by omission. After the quarrel, the topping up of the oil reservoirs simply stopped. The Timken fitter, affronted, wouldn't do it. The railwayman, equally affronted, wouldn't do it either. And so, nobody did it. A petty human falling out, the kind that happens in every workplace on Earth, quietly draining the life out of a multi-million-pound locomotive, one untopped reservoir at a time. The reckoning came near Luton. A bearing, starved of oil, ran hot. A hot box, in the old railway phrase, the dread of every driver. A bearing overheating towards seizure and, potentially, towards a wheel locking solid at speed and throwing a train off the road. When they came to investigate, what they found was almost unbelievable. Of the 7 axle boxes still in service, 4 were bone dry, and the others held nothing but rainwater, a locomotive at speed on a main line, its bearings running on nothing but neglect and weather, because 2 men couldn't be reconciled over an oil can. It was very nearly a fatal wreck, and it was very nearly caused by nothing more than a sulk. They got her stopped. But now came the moment that broke her for good, and the terrible irony is that it was an act of skill, not failure. An axle had effectively seized. To move her at all, Jim Lowe, the man who understood her better than anyone, who could make her sit up and beg, reached for his old virtuoso's trick, the scoop play that added the couplings inertia to force her along. He used everything he had to drag that crippled machine clear. And in doing it, according to the family's account, he overtorqued the transmission, put through it to shift the seized axle, forces far beyond anything it was built to bear. The gearbox that had already been shattered once by a bolt, painstakingly rebuilt over a year, was now wrenched and strained past its limits by the very effort of saving her. John Fell's verdict was quiet and final. After that, she was never the same. The colonel refused to lay the blame on his gearbox, and there was justice in his refusal. The gearbox, he insisted, was no more to blame for the bearing failure than the engine of a motor car is to blame for a puncture. The bearings had failed because nobody oiled them. The gearbox had suffered because it had been used, heroically, to rescue the wreck that neglect had made. That was all true. But truth is not always any use. She was damaged now in the one place she could not afford to be damaged, and everyone who knew her knew it, and her rivals knew it too. There is one image from this period that says everything about where the Fell now stood in the world. As she sat broken down after the Luton affair, an English electric executive passed her on another train and leaned out of the carriage window as it went by and shouted at the stricken machine and the men around her. "See what I mean? See what I mean?" That was the temperature of it now. Not a debate between engineers. A rivalry gone personal and cruel. A man jeering out of a train window at a broken locomotive because the broken locomotive stood for a whole idea he wanted dead. The electrical men could smell it. The Fell was faltering, and the moment was coming when the entire weight of British Railways policy would come down on the side of everything she was not. It came in 1955, and it did not come in a whisper. Chapter 12. The Plan. In December of 1954, British Railways published a document with a dry and enormous title, The Modernisation and Re-Equipment of British Railways. In January of 1955, it was announced to the country by Sir Brian Robertson, the chairman of the British Transport Commission, a soldier turned administrator, a man used to moving vast things according to a plan. And what he announced was vast indeed. The figures alone tell you the scale of it. Expenditure of £1,240 million, spread across 15 years. A sum that would, in the event, swell past 1,600 million before it was done. 2,500 new locomotives to be procured within about 10 years. It was one of the largest capital undertakings in the country's peacetime history, and it was meant to drag Britain's exhausted railways out of the age of steam in a single decade, and buried in its logic, without fanfare, was the death sentence of everything the colonel had built. The plan committed British Railways to diesel-electric transmission as the standard for mainline power. Electric drive, the power station on wheels that Fell had spent his life arguing against, was to be the future, everywhere, with only a small diesel hydraulic exception permitted on the Western region. There was no line in the plan for the diesel mechanical, no place for it. The intellectual groundwork had been laid years before in a 1951 report on the types of motive power that had already pointed the industry towards large-scale diesel and electric experiments. Now that direction hardened into policy, and policy into procurement, and the Fell's whole approach was stranded overnight, not defeated in a fair fight, but simply written out of the future by a committee that had decided the question elsewhere. The desperation of the thing made it worse. The plan had meant to proceed carefully, a pilot scheme of some 170 locomotives, to be built and evaluated properly before anyone committed to bulk orders. But the caution collapsed almost at once in the rush to get diesels on the rails. Order followed order before a single machine had proved itself. By May of 1957, 230 locomotives were on order without one example yet in service. In a stampede like that, there was no room at all for a solitary, complicated, twice-wounded mechanical prototype. She wasn't rejected. She was simply left behind by a railway running, headlong in the other direction. For Derby, the plan was a catastrophe, and John Fell's account of what it did to the place is among the most painful things in the whole story. The great works that Evatt had fought to keep in the game, that the Fell was meant to keep in the game, was gutted. Evatt himself left, gone to the firm of Brush. Hundreds of part-built steam locomotives, the last of a tradition, were dragged out and scrapped half-finished, and the talent hemorrhaged away. Skilled men who had spent lifetimes learning their craft found there was no longer any craft to practice. The family remembered one lathe operator, a man of real skill, refusing the demotion the New World offered him with a line that carries the whole grief of British deindustrialisation in it. "I'm not spending the rest of my days operating a bloody capstan." Derby, which had designed and built locomotives, was reduced towards being merely a place that maintained them. The colonel watched it happen, and he never wavered in his reading of it. The decision, his son said, was in his father's eyes nothing less than the death knell of the railway industry, the moment Britain chose to buy its future in from outside, rather than build it at home, and let the skill drain out of places like Derby forever. Somewhere in the middle of all this, in 1955, a quiet transaction closed the circle. The consortium, Fell Developments, Shell Ricardo, sold 10,100 to British Railways. She had been theirs. Now she was BR's outright, and Fell Developments Limited, its work done and its locomotive gone, was wound up. The company that had been formed in a city office to change the future of British traction was quietly dissolved, its one creation now the property of an organisation that had already decided it had no future at all. She ran on. That is the strange, sad thing. Through the middle 50s, she kept working her Manchester trains, damaged gearbox and all, an orphan doing her orphan's work, while the industry rebuilt itself around her, in a shape that had no place for her. She was a survivor of a purge that had already, in every way that mattered, killed her. She lasted until a night in October 1958. And then, in the most ordinary and humiliating way imaginable, she caught fire. Chapter 13. The 16th of October. It began in the boiler. Not the engines, not the gearbox, the boiler. She carried, beside that great transmission, an oil-fired boiler whose only job was to make steam to heat the passengers' carriages, the most mundane fitting on the whole machine. On the 16th of October, 1958, at Manchester Central, it caught fire. There is a conflict in the record here, and it is worth being honest about because it is the kind of small human thing that tells you these events really happened to real people. Nearly every source says Manchester Central, which is right, operationally, because Central was the terminus of the Midland route, expresses the Fell worked. But John Fell, in his memoir, says Manchester Piccadilly. It is almost certainly a slip of memory, an old man misremembering one great grimy Manchester station for another, decades on. We say Central because that is where she would have been, but we note the Sun's version because it is the kind of error that only affection makes. The fire took hold. It did her serious harm. Considerable, severe damage, enough that there was no question of her simply carrying on. Whether anyone was hurt, we do not know. It is one of the honest gaps in this story, and it should be left honest. No source we have found records any injuries, nor does any source describe the human scene of it. Who was aboard, what they did, how they got clear. The most complicated locomotive in Britain caught fire in a great city station, and the human circumstances of that fire have simply not come down to us. We can imagine the boiler alight, the smoke, the shouting, the crew scrambling. We cannot honestly say more than that. Some things the record keeps to itself. She was finished, and everyone knew it at once. They coupled her up and towed her home to Derby, the works that had built her, drawn her out of the paint shop 8 years before with such hope. And there, at Derby, they put her in a corner of the yard in sidings the railwaymen called the Klondike, and they left her. Now the question, after the fire, would they repair her? They would not. And here is another of the honest gaps, and it matters. No source we have names the man who made that decision, or the committee, or the meeting, or the grounds set down on paper. Nobody wrote down in any record that survives to us who chose to let her die. It appears simply to have happened. A machine too damaged, too complex, too costly, and above all too pointless in the world the modernisation plan had made, quietly deemed not worth the saving. The repair was uneconomical. But no name attaches to that verdict. She was condemned by an absence, by nobody in particular, by a future that had already moved on. And you have to remember, they had already lost interest 6 years before when the bolt went through the gears. The fire did not change BR's mind. There was no mind left to change. The fire only gave everyone the excuse to stop pretending. So she sat in the Klondike sidings, and the stripping began. Slowly. That is the word the records keep using. Slowly stripped of parts. Through the winter and into 1960, men came and took pieces of her, whatever was worth having, unbolted and carried off. A locomotive dismantled the way you might dismantle an argument, one point at a time. By the spring of 1960, she was described as rotting in the yard, sharing her disgrace with another failed prototype, the 10,800, the two of them left out in the weather like animals waiting for the knacker. and in July of 1960, they finished it. The remains of 10,100, the strangest, most complex, most ingenious locomotive Britain ever built, were cut up for scrap. 10 years, near enough, from the contract to the cutter's torch, of which perhaps 6 had been spent in any kind of service, and one of those lost to a single bolt. There was no ceremony, no preservation, no last run, no plaque. The men signed nothing, the way workers at other places would one day sign the last car off a line. They simply cut her up in a corner of a yard and carted her away, until there was nothing left where the 6 engines and the 60 cylinders and the great impossible gearbox had been. John Fell, who had spent every Saturday of his youth watching her being born, allowed himself, years later, one small unscientific thought about how she died. It was, he admitted, his own rather emotional fancy, but he had always felt that she had died of a broken heart. His father did not indulge in such fancies. His father did something else entirely. His father started again. Chapter 14. The Model at York. Louis Fell was 66 years old when they cut up his locomotive. Most men at 66 would have taken it as the end. He took it as an inconvenience. He had, around this time, done something his son thought certifiably mad. He gave away all his patents, the whole intellectual inheritance of 10,100, everything he had drawn and fought for and proved, to Rolls-Royce. For nothing. Gratis. John thought his father had lost his mind until he understood the strategy behind it, which was the strategy of a man who cared more about the idea surviving than about who owned it. Rolls-Royce had the money and the reach to carry the thing forward. So Rolls-Royce should have it, and Rolls-Royce, in return, gave the colonel a department. At 66, appointed most likely by Denning Pearson, Fell became manager of Rolls-Royce's new rail transport department, first at Derby, then out at the old Sentinel Works at Shrewsbury. And the first thing he did was gather his people. He brought in Ken Tyler, the Ricardo man, who had nursed the power plants of the Fell at Derby, and had followed the colonel loyally onward. He brought in Bernard Moultrie, a man who would be killed, heartbreakingly, in a car crash in 1961 on his way to a meeting, a loss that devastated Fell. He brought in others, and he set them to work resurrecting his idea under a new name. They called it high diff. Fell's power-adding differential, the gearbox that ran backwards, reborn inside Rolls-Royce. It went into a twin-engined locomotive called the Taurus, built by the Yorkshire Engine Company. And then, in 1963, it went into the machine that was, in every way that counted, the true heir of 10,100, a locomotive called DHP-1, built by the Clayton Equipment Company. A 1,500 horsepower, 4-engined mainline prototype using Fell's multiple-engine principle, but replacing the old supercharging trick with modern torque converters. It was the Fell reborn, cleverer and cleaner, everything the Mark II might have been. DHP-1 never hauled a single revenue train. By the time she was ready, the railway had moved on again, into the collapse of the Beeching years, the Great Contraction, a world with even less appetite for a radical new locomotive than the one that had rejected her ancestor. She was broken up in 1967, unwanted, having proved nothing to anyone who was still listening. Had she ever earned a number in the old experimental series, she would logically have been 10,101, the next in the line. She was, as the enthusiasts say of her, simply born at the wrong time. The whole of Fell's life could be written under that sentence. And yet the idea did not die, because the thing the colonel believed, that you should distribute power through many small engines, rather than concentrate it in one great one, was not wrong. It was merely early. Look at the railways of Britain today, and you will find his idea everywhere, though almost nobody knows to call it his. Every diesel multiple unit, every sprinter, every busy commuter train, every Trans-Pennine Express that runs today over the very peak the Fell once climbed, carries its power distributed among small, standardized engines spread through the train. The principle of shared, distributed power that Louis Fell drew on a board in his bedroom, and that British Railways rejected in 1955, became so completely the ordinary way of things that we no longer even see it. He lost every battle and won the war, decades after his death, without a monument to show for it. Louis Frederick Rudston Fell died on the 27th of November, 1977, aged 85, and was buried in a quiet Lincolnshire churchyard. He had lived long enough to see the multiple unit begin its conquest of the railways. Whether he ever quite let himself believe he'd been proved right, we cannot say. Of the locomotive itself, almost nothing survives. No Paxman engine, no cylinder, no combustion chamber, no length of that great frame. There are no sound recordings. The men who make the sounds for the model version have to invent them, because not 1 second of the real thing was ever captured. There are a handful of photographs. A shot of her working in 1957, near the end. The bleak 1960 images of her being cut up in the yard. And in 2021, a model firm produced a small 00 gauge Fell for enthusiasts, the nearest thing to a resurrection she will ever have. A toy of a machine that most of the world never knew existed. But there is one real thing left. One. At the National Railway Museum in York, in the open store where the overflow of the collection is kept, there is a working model of the Fell transmission. Not the gearbox itself, that went for scrap with the rest of her. A model of it, built by Rolls-Royce, small enough to sit on a table, its gears still turning, still demonstrating the beautiful backwards logic of the power-adding differential that Lewis Fell spent his life on. That is what remains. The most mechanically complex locomotive Britain ever built. 6 engines, 60 cylinders, a gearbox like an elephant with a throne on its back, a machine that beat steam over the Pennines and cleaned the tunnels as it went, has come down to us as a tabletop model of the one idea inside her that was always going to outlive the iron. Go and find it, if you're ever in York. It sits quietly among the other relics, turning its little gears when someone sets it going, saying nothing about the man in the bedroom with the drawing board, or the mother helped up into the cab at Eastbourne, or the driver who could make her sit up and beg, or the bolt, or the fire, or the sidings called the Klondike where they finally cut her up. It just turns, which is, in the end, all the Colonel ever wanted it to do.